All right, this is problem number 90 out of chapter 4 of the Halliday and Resnick textbook. So here we go. We've got this basketball guy over here, and the question says, at what initial speed, so we're trying to find our V naught, does the basketball have to be thrown at if he throws it at an angle of 55 degrees above the horizontal to make the foul shot? And then it tells us that horizontally it's going to go from a position of 1 foot to a position of 14 feet, right? So the idea is from here to here, our x value is going to be, 13 feet. It's got to go from 1 foot to 14 feet. So that's a difference of 13 feet. And then vertically, from the moment of release until it hits the net, our y value is going to be, well, it's got to go from a height of 7 feet up to a height of 10 feet. So that's 3 feet, right? Okay, so what I'm doing basically is I'm just saying, all right, well, let's make this our origin. So this would be a position of 0, 0, and then we're measuring everything from there. All right, now the next thing we got to do is deal with the fact that these are stupid feet instead of good old metric numbers. So somewhere on my paper, I've done those conversions. Oh, I lied. I did not do the conversions. I just left everything in feet. That's cool. So what I need to do then is, when we solve this, we're going to use, instead of using our acceleration of gravity is negative 9.8 meters per second squared, or I guess I should say instead of using g is 9.8 meters per second squared, we're going to use 32.2 feet per second squared. And then we don't need to convert stuff. All right, so this problem doesn't say anything about time, but what we want to do is figure out what the starting velocity has to be so that when we've moved horizontally a distance of 13 feet, we're at a vertical position of 3 feet. So because time isn't in here, and it looks like I'm relating x to y, that leads me to think in the direction of using our trajectory equation. All right, this is one of those big equations that you just got to kind of memorize. It's really one of the only, two equations that are specific to projectiles, right? So here's what that trajectory equation says. It says that at any given instant, the vertical position of a projectile is equal to the tangent of theta naught times x minus g x squared all over 2 v naught cosine theta naught, and this whole mess here is squared. So this really is just our vx, right? Vx squared. Okay. So, and again, I gave you guys that equation in class, and if you want to see where it comes from, I'm happy to show you, but it basically just combines some of our projectiles equations. The Vx and the Vy equations, I think, are the ones that it uses. Okay, so anyway, so at this point, it's basically just plug and chug. We know our x, we know our y, we know our theta naught, and we got to find our v naught. All right, so I'm going to kind of plow through these equations here. Kind of clear up some board space first. All right, so here we go. I'm just going to start plugging in numbers. Let's see. We know that our y value is 3. That's got to equal the tangent of 55 degrees times 13 minus, remember g is not 9.8, it's 32.2 times x squared, so times 13 squared, all over 2 times v naught squared times the cosine of 55 degrees squared. So we got to algebra this thing. So how did I do this here? All right, so let's move this mess to the other side and move the 3 over. So we're going to get 32.2 times 13 squared all over 2v naught squared cosine of 55 squared equals tangent of 55 times 13 minus 3. All right, so then let's get rid of everything except for the v naught. So I'm going to end up with 1 over v naught squared equals this mess, tangent of 55 minus, times 13, minus 3. And then I got to move everything else here, right? So I'm going to have to multiply by 2. I'm going to have to multiply by the cosine of 55 squared. And then I'm going to have to divide by 32.2 and 13 squared. Okay, so solve that giant mess, and you get that 1 over v naught squared is 0.001888211, which means that v naught squared is just 1 over that, which is 531 or something like that, and then square rootify both sides, and your v naught turns out to be 23 feet per second. All right, there you go. Trajectory equation. Lots of fun. All right, there you go.